Hey, g'day, it's Prezzo here. Thanks for joining me in the workshop again today. Now, as you can see, I've got a new sticker on the board today, and this came all the way from Portsmouth in England, and it belongs to a gentleman who runs a channel called the Knackler's Workshop. Now, I had to look this up. This is a colloquial term used around Yorkshire, and it's used to describe someone who can fix anything. Now, that's certainly not me, but if you have an interest in the MIXIE Unimat SL lathe, and this was a little lathe that I coveted dearly when I was a teenager. I desperately wanted to own one, but sadly my parents wouldn't shell out the money to buy one, and it was many years later before I got my own lathe. But the gentleman that runs the Knackler's Workshop is a bit of an expert on the MIXIE Unimat. He owns one, he's restored one, he uses it regularly, and if you are interested in that particular lathe, he's the go-to reference. Now, when it comes to fixing things, I generally consult with my flowchart over here, so let's have a close look at that. As you can see, this is a very clear flowchart, and you want to start here and you want to end up here, and how you get there is totally up to you. But my advice, stick to the left-hand side. No problem. Okay, today's video is all about making parts for my MIXIE clock. Now, a MIXIE clock is a mashup of steampunk, industrial style, bit of art deco, and it's a backlit LED digital clock. And I've made a playlist if you want to go back and look at the first two parts of this build, but the bits we're making today are all done on the lathe and the milling machine, and they consist of this donut shape here, which is used to mount on top of this copper arm, and this will allow us to fit a wire up from the cast aluminium base through the arm, through the hole in the donut, and it also needs to go down through this hollow in the center of this brass screw, which we're going to make today as well. So let's head over to the lathe and let's start making which part. Let's do this first. To make these screws, this is 19mm brass stock. Head diameters have to be 16, but it's the nearest I had to the size that I need. Well, that's pretty much the plain turning done. I've just got to part this off now at the correct dimension. And I know from watching Joe Piesinski that he does that trick with the razor blade, but it doesn't always work, especially when you're working from the shoulder like this. So what I tend to do is use a piece of feeler stock. This is 0.03, and I just run the parting tool blade in until it pinches that feeler stock, and then I know that that's a 3/32 parting blade, so I advance my top slide or compound slide by that amount and then set my DRO to 0. So I'm just advancing the compound now to 3/32. So 0 the DRO. Now this head's got to finish at, what's that, 7.6. And I'm going just a fraction over there, so 7.62, just so I can skim that later on. Now this is an inverted parting tool, so you've got to run the lathe in reverse. Sort of medium RPM. Oh, Mark, I said medium. So there's the finished part at this point. I've just got to put a shoulder on this side here, and this has got to have a dome shape added to that later, but I'm going to leave that till we've made the next part, which is that donut, because the setup requires fitting the tornado to the lathe. We'll look at that shortly. So I'll just get the shoulder on this one. That little shoulder's got to finish at 14 diameter. Well, there's one, and there's four. And like I say, we'll do the decorative turning on the head of this later. Now this next part is quite a chunky piece of brass, and I don't have a lot of stock of this size, and I just rough one out here just to give you some idea of how big this part really is. Now I don't have a lot of stock for this, but this is some material left over from a casting that I did for another job, and this was the feeder, and I got this one out of that piece of stock there, and you can still see the cast texture on the outside of it there, but this is going to be removed later. So I've got enough there to make probably two more if I'm lucky, but the problem is that there's a great big shrink hole in the end of that feeder there, and I'm not sure how far down that goes. So we'll get one more out of this and see how we get on. I have got another piece, but it's much bigger in diameter. It seems like a waste to cut it down to this diameter here, but if I have to, that's what we'll do. Pretty sure this is already the right diameter, this stock that I've got in the chuck here. So this is 32 diameter, and that is, yeah, it's a bit under actually. Sort of 32 there, but it's a bit under on this side here. That's alright, it's going to be shaped like a donut anyway, so it's going to be rounded off on this outside face. Well, if you saw that, you'll know that I've actually reached that shrink pipe in the center of that stock there. Now, I may get one out of this, I'm not sure. Let's just keep going. But I know this drill's going to start running out, so actually I'm going to cut that undersize. Yeah. I'll try and bore that close to the finished size. It's got to finish at 3/8 of an inch, and it's got to be reamed. I may get away with it. We'll find out. I don't think I'm going to waste any time on that. I think I'll part that off and just see what it looks like on the other side. If it's any good, I can bore and ream the hole later. But I could go to a lot of trouble here and then part it off, find out it's rubbish on the other side. Alright, now this might get ugly. Alright, did I tell you how much I hate parting off? I think I got away with that. The diameter on the inside there is a little bit erratic, but all of the stock around the hole there is okay. So I'll put this in the chuck and bore that out and ream it to, what was it, 3/8. Yeah, I'll ream that to 3/8. And I've got two good ones, and I'll get probably two out of the other piece of stock that I've got. Well, I'll run this little boring bar through and see if we can get that close to 3/8 of an inch, but the inside of the hole is not perfect, so it's going to influence the tip of that boring bar. that's usable. It's not perfect, but as you see later on, it's going to be decoratively turned on the outside, so I think we're going to be good with that one. So I'll go ahead and get 2 more made out of the other piece of stock. And this is the other piece of stock. This was actually cast in a sand mold, so it's actually good on both ends, but it's way bigger than what I need, and it does seem like a waste. But it was cast from scrap, so I'm not too bothered. Well, just so you know, I did get all 4 of those pieces out of that bit of cast feeder. The last one that I did was a bit ugly. It's got quite a large irregular cavity on the inside of that, but even if I put the screw head on that side, it's still covered up, so I think that's usable. And I've still got my nice piece of cast stock to use at another time. And it always amazes me when I watch Jimmy DeResta and he says, "Oh, I just made this thing out of a bit of 2 foot long piece of 2-inch diameter brass." And I think, how much did that cost? Yeah, I'm a bit stingy. If I can get it out of scrap, I'll do that. And what has to happen with these parts is they've got to screw onto this cast aluminium disc. And in order to do that, I've got to put a screwdriver slot in the end of the screw. And I want to do some decorative turning on these parts. So the top of the screw will be domed, and this particular part here will have a full radius, 16mm radius on the outside of that circumference there. Now, in order to do that, I bought a special tool for doing the job. So let's have a look at that. Well, this is it here. This is called a Tornado freehand turning attachment for a lathe. And this is capable of doing both concave and convex cuts. So I can get that off there. Okay, that fits on there. And now we can do convex cuts. And it can be set to any radius up to a certain point. And I've made a special tool for doing that, and we'll look at that shortly. Now, when you buy the Tornado, you get the tool holder itself. You get this little setting pin which can fit into any of the holes on this auxiliary table. And the only thing you don't get is this riser. Now, I had to make this to suit my Colchester lathe because it's got a larger centre height than most of the smaller hobby lathes. If you own something like a Myford ML7, you'd get away without that. You just have to shorten these little columns here. But for my lathe, that brings it up to the correct height. Unfortunately, the process for getting compound slide off Colchester is not a simple one. There are 2 nuts inside these slots here underneath the compound, and you don't have a lot of access. Got a little tiny spanner, can't see what you're doing. So, yeah, it's a bit frustrating. Anyway, I'm going to get this swapped over, and then we'll put the Tornado on here, and we'll get into some freehand turning. Now, to fit the Tornado, you've got to take the top plate off, and that's fixed with a single screw in the centre there. Then I've got access to the top of the studs, and we just got to bolt that down. And there's no real requirement to align this auxiliary table with anything on the lathe. There may be some setups where that's critical. But for what I'm doing here, it doesn't really matter because you can use any hole in that auxiliary table as a pivot point. So yeah, in this case it doesn't really matter, I can just sort of bolt this down anywhere, and you just pick an arbitrary hole as the pivot point. So top plate goes on again. Just located by these 4 pins on the end of the studs. Alrighty, so we're pretty good to go. Now, to hold these brass blanks, I've got an aluminium mandrel in an ER40 collet chuck, and that just fits over the Tornado auxiliary table. So I'm just going to mount those with a washer and a socket head screw. And then we can wind the auxiliary table on the Tornado to a convenient position, and then you can put one of these pins in any of these holes. So if we leave that one there, we want to position that pin so so it's roughly in the center of the blank, and then we can rotate the tool bit left and right. Now I won't be able to rotate it all the way around to get the curve on the back side, but what I can do is just flip the part. So we'll go and get the radius set correctly on the tool, and then we'll come back and we'll have a go at this. This is a fixture I made for setting the tornado, and it uses the same pin that came out of that auxiliary table, and it drops into that hole there, and there's a hole on top. Okay, there's a hole on top here which is concentric with this hole in the base here, and what I can do is I can screw a circular disc of acrylic into that hole. Now I've got a whole bunch of these, and I've made both metric and imperial sizes, and with that set in there, we've now got like an extension of the radius that we want to produce on that brass part. So now we can put our tornado turning tool into position there and set the position of the tool bit so it tracks around that 16 diameter. So let me just set that. So underneath here there's a single locking screw which you loosen, and then this whole shoe or plate, whatever you like to call it, can move backwards and forwards. So we push that shoe onto the pin on the base here, and then we slide the tool bit in until it's touching that 16 diameter piece of acrylic, and then very carefully take that off again, and without disturbing it you can tighten up the screw underneath. Now you can get some fine adjustment, so you can actually loosen this screw here, and then you can wind the whole carriage containing the tool bit backwards and forwards, and if you're not quite sure if you got it, you can make the adjustment that way. Now that also has the effect of raising and lowering the tool bit as well, but you're not moving it very much. I don't know if you can see that, but that tool is tracking away from that circular disc, and now it's moving in towards it. And it's largely a matter of just sort of feel. I'm pretty sure that's correct. And we can make some fine adjustments when we start turning the part. Alrighty, so that's ready. So let's go and give it a try. And I think all you need to do here is just put this pin in any convenient hole. In my case, I don't want to go too far toward the outer edge because I would have to push my cross slide all the way back. But I think with that I can get it. And then the idea would be that we rotate that around and then just bring the tool bit in until it bears on that face. Now if we've set our radius correctly on our tool and our stock is the correct width or thickness, then that should work. A bit hard to tell. I think I'm touching there. Yeah, I think that's touching. So now we can wind that out, and then our tool tip should be directly over the center of that thickness, whatever that is. And then of course as we wind the tool in, we'll begin to cut this corner off here, and then we'll just go all the way around until we've got like a half radius on this outside face. Tell you what, that is so satisfying. And it's perfectly safe. I mean, the tool tip is back inside the front edge of this shoe here, so with the downward pressure on it, it's always seating the tool shoe down onto the table, and it can't tip or get out of control. And when I've got to this point, I can set my DRO to 0, and then when I flip the part around, as long as I go to the same setting, I should match up with this diameter here. So let's do that. Now, there's a bit of a step in the center there. It's going to need some finessing later on just to blend that in, but overall I reckon that's brilliant. It's so easy. And of course, the only thing you want to be sure of now is you don't move the table longitudinally. So it's probably a good idea to lock the saddle. I haven't done that, but probably should on the next one. Okay, let's go again. Don't know if you noticed, or on that last cut, I just had to move the table in towards the headstock just a fraction. It was just leaving a hard edge there, and that seems to have blended that in quite well. Now these need a lot more polishing, and I'll do that later. There's that one done, and like I say, there's a bit of tidying up required to finish these off properly. But overall, I reckon that's fantastic, and I don't know how I would have done that any other way. I've got a ball turning attachment, but it's a big cumbersome thing. It's awkward to set up. You can't always get the radius that you want, but with this you've got total control, and you can see what you're doing, and it's repeatable. You can sort of set it up and get the same result again and again. Anyway, let's get the others done. Well, there's the 4 of those done now. You're going to need a bit more dressing and polishing later on, but for now they're good. And what we need to do next is to put a domed end on this screw here, and that'll eventually be slotted on the milling machine. So we're going to set up for that. Now it's got a radius of 16mm across that raised boss there. So I've got my 32mm diameter disc in that, and we just need to set the tool bit against that disc and lock that. Just got to be a little bit careful when you turn that over, you don't move it too much. Okay, so I've got one set up in the lathe in the 40 chuck, so let's go and do that one. Well, just struck my first problem here. This pin won't fit underneath the body of that ER40 chuck, so I've got to get a lot closer than what I am there now. When Eccentric Engineering sells the Tornado kit, they also sell an ER32 collet chuck with a modified nut on the end of it, and it's designed to get over that pin. Now I don't have an ER32, I got an ER16, so I'm going to set that one up and we should be good. Now I've got the ER16 in here now and everything fits. Right, with the pin there and the shoe there, all we have to do is to make sure the tip of the tool is more or less on center. Now I've just eyeballed that. You can make minor adjustments as you go along, but we'll give that a try and see how it works. There's still a sharp edge on the very outside corner of that screw head there, and I want to chamfer that. Now, one of the things that gets supplied with the Tornado is the tool bit, which is double-ended, and the other end has a very shallow radius on it, and it's designed for doing finishing cuts, but in this case I can use it to put that chamfer on there. So without using the pin, I can just push the tool bit straight against that corner. Well, that one's done, and it'll need a little bit more polishing and care and attention later on. The screwdriver slot needs to go in on the milling machine, and I'm waiting on a 1.2mm slitting saw to do that. And if we catch up with that by the end of the video, good. Otherwise, we'll see it in the next episode. The last operation with these donuts is to drill a 1/2 inch hole right in the very center over the axis line of that donut there, and that's to fit this 1/2 inch copper water pipe. Now, do I own a 1/2 inch end mill? No, I do not. Do I own a 1/2 inch slot drill? No. Have I got a 1/2 inch drill bit? No. Have I got a 1/2 inch machine reamer? No, I have none of those things. Do I have it in 12mm metric? Yep, got all of those. So, but it's got to fit 1/2 inch copper water pipe. So the nearest I've got is a 12.6mm drill bit, and I'm just hoping that drill's oversized for once. That's near enough, I'll take that. If you're wondering about this brass, this was originally cast from scraps of sheet brass, and it's not like free machining brass that you might buy in bar form. So it's a bit, I don't know, it's a bit malleable. So it does raise these pretty awful burrs. That's pretty much got rid of the raised section. And because the drill bit was chattering a bit, it sort of bored that hole a little bit oversized, which is actually a good thing. The copper pipe sort of jams in there fairly well now. Doesn't go in a long way, but that's okay. Now there's another ugly burr on the inside there, which I'll need to clean out with a reamer and a file. So we'll do that, give these a final polish, and we're nearly done. Here's one mounted on the aluminium disc that goes on the end of the clock. And what we need to do now is to bend up the copper arm, which is going to support the whole clock over the base. So I'm hoping I've got time to do this, but let's go ahead and see if we get one of these bent and cut the shape. Okay, the last part of this episode today is to get the copper arms made that will allow us to support the clock frame over this cast aluminium base. Now a lot of this is just really straightforward copper fittings and just cutting copper tube and so on. So I cut these two little risers here, and they're just jammed into the cast bosses on this base here. There's a connecting tube that will fit in between the two T-pieces like that. And later on I'm going to fit some fake steam flanges to make it look like all these pipes are joined together with bolted flanges. But we'll do that in the next episode, but they're going to fit on there like that, and I'll have nuts and bolts around the face of that flange there. But for the moment what we need is this arm, which is going to come up and has to be curved. So I've got a longer piece of copper tube here. I've got a plumber's pipe bender, And I've got a template which I've already made out of a bit of plywood. So this is where the end of the tube has to fit. This is where the other end will be. That'll be the vertical end, and the curve is going to go along here roughly like that. So the trick with this, well, I've already done all of the geometry. This is the very center line of the clock here. This is where the tube needs to join into those brass bosses that I've already made, and I've sort of worked out all my offsets and so on, and I've double checked that and I'm sure it's correct. Now I'm just going to bend this tube slightly oversized, and we'll fit it into this this jig here and mark off the two end points and cut them. You sort of need 3 hands to do all of this stuff, but I think the tube fits through like that. Make sure that little hook there is down. It's going to trap the tube, and you want to leave plenty of copper up here. You know, it's probably best to cut it or bend it way oversized. Alright, so this is the way it works, and we're going to just pull that around. Now I'm going to go off camera and do this because you've got to put your knee in there and you don't want to see my doubly knees. How's that? I made the appropriate noise then. Now chances are that's not 90 degrees, but we can check it. And this is why I've got these 2 pieces of wood which are just nailed on there. You know what? I think I fluked that, got it exactly right. Now, we can just mark off the ends. So I'm going to cut it just there and just there. Okay, where's my pipe cutter? Alright, so there's our bit of bent pipe. Here's one of our marks here. And if you don't have one of these tube cutters or pipe cutters, you can do it with a hacksaw. Doesn't really matter what the end of the tube looks like. Right, second cut there. So there's one. I'll get a second one made and we'll have a look at it all fitted up. Oh, there you go. It's starting to look like the picture, isn't it? And I've got this sort of just all balanced here at the moment. If I touch it, it's likely to collapse, so we'll just look at it. And in the next episode, we're going to try and tackle some of these parts up on top of the wooden clock frame, and we'll try and get these fake pipe flanges made as well. And normally when I finish up a video, I would show you some of our local birds and wildlife, but not today. We're going to the beach, so get your bucket and spade and your towel, and I'll meet you in the car. Well, here we are, folks. We've arrived at the beautiful Noosa Beach, sometimes called Noosa Main Beach, on the shores of Laguna Bay. Now, there's a beautiful walk down through the she oak trees and the rainforest. When you arrive at the beach, you're looking out over this beautiful expanse of white sand. Now, the surf here is never particularly rough, and I'll explain why later. And looking down toward the other end of Noosa Main Beach, you'll see Noosa National Park, or Noosa Heads, which is a protected area. And looking the other way, you're going to see the mouth of the Noosa River and what's known as the North Shore, which takes you up to the Great Sandy region opposite Fraser Island. Now, there's a beautiful boardwalk that takes you down the beach toward the cafe district, and I'm going to take you to our favourite cafe in the whole of Noosa. It's called Bistro on the Beach, and if you get this corner table that you can see right here, you're absolutely golden. But even if you don't, you get to enjoy the beautiful coffee and fresh muffins and this $1 million view. And as you can see, if you get the corner table, you're just like literally meters from the beach, and you get the view that goes with it. So that's Noosa. I invite you to visit if you've never been there, if you live overseas and COVID willing. If you get the chance, pay it a visit. It's an absolutely beautiful place. Well, I hope you enjoyed that little trip to the beach. Now, a few fun facts. Noosa Main Beach is about 25 minutes drive from where we live up here in the hinterland, and it's one of only 2 north-facing beaches in Queensland. Now, that's important when you live in the southern hemisphere because it means that the sun is on the beach all day long. It's also important because it doesn't face the prevailing winds, and we don't tend to get the choppy surf that you get a bit further down the coast where the beaches face east. Now, the Noosa River is the only river in Queensland that doesn't have its source in the mountains. All of the water of the Noosa River comes out of the Great Sandy region adjacent to Fraser Island. and the water just percolates up out of the sand, and it's always clear and clean, and I think our river has a AAA rating at the moment. Now, Fraser Island is the largest sand island in the world, and it's well worth a visit in its own right. Now, if it sounds a bit like I'm bragging, well, maybe, but I don't for a second take for granted that we live in a very safe and beautiful part of the world, and many people don't have that luxury. So when COVID is finished and people are travelling again, I invite you to come and explore the region. It is really well worth the visit. Now, that's all in this video today. In the next video I'm going to do some more tricky parts for the MIXIE clock, and I invite you to come along and have a look at that. And for now, thanks for watching, and I'll see you on the next video. Cheerio!